Today, we're going to get a high-level overview of the next section in our textbook, sections 5.5 to 5.8. First, we want to look at what are our objectives of this video and of this section. Alright, so by the end of this video, you're going to be able to list each of the 10 theorems that you're going to see and we're going to work with over the next sections in the chapter. At the end of the video, you will be asked to sign into Moodle and list each of the 10 theorems. If you write them down as we review them and as we go through this step, this assignment should be very easy. Okay, so the first one you should all be familiar with because we came to this conclusion as one of your exercises when we looked at the lengths of the sides of a triangle. This is called the triangle inequality theorem. And basically all it says is that the sum of two sides of a triangle must be greater than the length of the third side. So if you take any two sides of the triangle and take the sum of their lengths, it's going to be greater than the sum of the third. Now I don't want you to remember this as theorem 5.5.3. That's not very helpful or meaningful. We're going to call this one triangle inequality theorem. So again, if you're writing these down or memorizing these, that's what you want to learn. Triangle inequality theorem is how we will refer to this. Next, we're going to look at two theorems that talk about the relationship between the angles and the sides. So the first one is we're going to look at two sides of a triangle that are not congruent. And the key here is not congruent. So we're going to look at the length of side AB in comparison to the length of side BC. So what we're saying here is if the length of AB is greater than the length of BC, then we're going to conclude that the measure of angle C, which is opposite the longer side, is greater than the measure of angle A, which is opposite the shorter side. And again, the key is that these two side lengths are not congruent. Alright, and we're going to look at basically the converse of this. Here we're going to start at knowing information about the angles. So the measure of angle Z is greater than the measure of angle Y. If we know those two things, then we also can conclude that the measure of XY is greater than the length of XZ. So again, we're seeing that the side opposite the greater angle is longer than the side opposite the smaller angle. Now, these theorems don't have names, so we're going to create ones that make sense to us, and this is how we will refer to them. So the first one, simply larger angle opposite longer side. The second one, longer side opposite angle. So let's review what we have so far. We have 3 out of the 10. The first one is the triangle inequality theorem. Second one, larger angle opposite longer side. Third one, longer side opposite larger angle. So again, the more you look at these, the more you repeat them to yourselves, the easier it is going to be to just remember them when it comes down to actually applying them and using them. Now let's look at one that involves two triangles. So this is really, you're going to see, it's basically the same thing we just looked at, but we've got two triangles involved. And again, we're looking at two triangles. And you'll see here that side AB and DE are congruent, and side AC and DF are congruent. So what we need for this theorem is two sides. We have two pairs of congruent sides on two different triangles. And now the given piece of information is that the measure of angle A is greater than the measure of angle D. Now the measure of angle A and D, those are the included sides. Okay, so we've got two included angles, and one important factor, again, just like in our last one, is these angles are not congruent. Okay, so if the angles are not congruent, measure angle A is greater than the measure of angle D, we can conclude that BC is greater than EF, which is the third side, which is the one that is not congruent. Now, we're going to look at the converse of that. So, Same thing, we have two congruent sides, and we're looking at the third side. Given that the third sides are not congruent, so we're looking at side GH and KL. If GH is greater than KL, then we can conclude that the included angle between the two congruent sides, so we're looking at the measure of angle J and the measure of angle M. Those are the included angles. So we've got the measure of angle J is greater than the measure of angle M. So it's really just like what we looked at before, except now that we're comparing sides and angles on two different triangles. You'll see that the longer of the two sides belongs to the triangle with the larger angle, and the larger of the two angles belongs to the triangle with the longer side. Let's review again just to really drill these in. Triangle inequality theorem, larger angle opposite longer side opposite larger angle, and the last ones we just looked at is known as the hinge theorem and the converse of the hinge theorem. Next we're going to look at one that's very familiar to everyone, the Pythagorean theorem. A squared plus b squared equals c squared. C squared being the hypotenuse or the longest side of a right triangle. We also have one that's a little less familiar. We have the Pythagorean theorem and we have its converse. The converse just tells us that supposing we don't know if it's a right angle or not, we might not know any of the measures of the angles, but we might be given all the sides. We can plug those values into the Pythagorean theorem equation, and if it evaluates to a true equality, then we can conclude that the triangle is a right triangle. Now we look at one that's even less familiar. Again, it's related to the Pythagorean theorem, but this one is called the Pythagorean Inequalities theorem. Again, we've got our triangle, C being the length of the longest side. Again, we're not giving any measurements of the angles. But what we are given is the side lengths. So we set up our equation, c squared and then a squared plus b squared. Now we need to determine what is the relationship between c squared and a squared plus b squared. If c squared is greater, then we know we've got an obtuse triangle. If c squared is less than the sum of a squared plus b squared, then we know we have an acute. And again, if it's equal, we know we have a right triangle. So again, remember, in a right triangle, the Pythagorean theorem tells us what is true regarding the hypotenuse or longest side. We use this information now to determine, based on the length of the sides of the triangle, what kind of triangle we have, obtuse, acute, or right. Again, let's review what we have so far. We have 8 out of the 10. Triangle inequality theorem, larger angle opposite longer side opposite larger angle, the hinge theorem, the converse of the hinge theorem, the Pythagorean theorem, the converse of the Pythagorean theorem, the Pythagorean inequalities theorem, and now we've got 2 more that deal with special instances of right triangles. First is the 30, 60, 90 triangle theorem. And in this one, again, we know the angles. They've given us at least 2 of the angles because remember, as long as we have 2 angles, we can find out the third. So in this case, we have a right triangle with the smaller or acute angles being 30 and 60 degrees. So if we are given one side, we can calculate and figure out the other 2 sides. And this just says that the shorter side, represented by S, the hypotenuse is 2 times S, and the longer leg is going to be S times the square root of 3. Our other instance or special circumstance is if we have a right triangle where the acute angles are 45 and 45. So this would also be an isosceles right triangle. Both legs are congruent, and the legs would be represented by length L, and the hypotenuse would be L times the square root of 2. So basically what this means is that with these special instances, if we have a 30, 60, 90 triangle or a 45, 45, 90 triangle, we can calculate the length of all the sides when we only know the length of one side, as opposed to the traditional Pythagorean theorem, which requires that you know the length of two sides. So for a final review, let's just look at what we have. First, we have the triangle inequality theorem, larger angle opposite longer side opposite larger angle, the hinge theorem, converse of the hinge theorem, the Pythagorean theorem, the converse of the Pythagorean theorem, Pythagorean inequalities theorem, 30, 60, 90 triangle theorem, and 45, 45, 90 triangle theorem. Now, go ahead and log into Moodle, enter these 3 points, and complete the assignment. Again, the goal of this video was only to introduce the concepts, so when you come to class, you will be ready to look at the practical applications of these theorems, and we don't need to explain or introduce all of them. You should all be familiar with these, so when I start to mention them in class, I don't feel like I'm on a different planet. Anyway, have a good evening, and we'll see you in class.